Okay, in this video, I'm just going to kind of review some of the things we talked about in class. So let's start by just taking a look at these statements. Remember, one of the things we looked at was finding the horizontal asymptote. Okay, this is a feature of our rational functions. So if the degree of the numerator and the denominator are the same, then we use the leading coefficient. And I'll give you an example here. You can see that the numerator and the denominator have an x with an exponent of 1. So the degree of the numerator and the denominator is 1. So they're the same. So we use this leading coefficient of 2 over 3. So 2/3 is going to be our horizontal asymptote, okay? That means it's shifted up, if you will, from 0. So we know that the graph is going to touch the x-axis at some point. So there will be an x-intercept. Now, if the expression is bottom heavy, or what I mean by that, if the denominator has the higher exponent, so in this example, you see that we have 4x squared in the denominator, and the numerator is just a 3x. Well, whatever you plug into x here, you should be able to recognize that the denominator is going to become the larger number, and that will just continue to get much larger. And if you have a smaller number divided by a larger number, then you're basically just going to always be approaching 0. So you can see your horizontal asymptote is 0. Now, if this is true, and if it's always approaching 0 but not touching 0, then you're not going to be touching the x-axis, because a horizontal asymptote of 0 means that the y equals 0, and it never touches 0. Okay, so we know that we're not going to have an x-intercept if a horizontal asymptote is y equals 0. All right, continuing on, if you have this one where that it's top heavy, where the degree is larger in the numerator than the denominator, then we do not have a horizontal asymptote, okay? And finally, or not finally, the vertical asymptote, you can simply find that by setting the denominator equal to 0, okay? Because we cannot have we cannot have anything over 0. That will make it undefined, and that's how we identify our vertical asymptote, okay? Now, the x-intercept, anytime we're trying to find an x-intercept, we can simply just plug 0 in for y, because that's what an x-intercept is, okay? When the y is 0, what was the x value? But you see what we worked on in class, really the shortcut is that you can just set the numerator equal to 0 if you want to find the x-intercept. And I'll show some examples here as well. And then in the y-intercept, if you want to find the y-intercept, you just plug 0 in for x, and you solve that. Now, of course, we talked about holes in class as well. And we identify a hole. What we do is we're going to plug that. The x value that we recognize creates a hole into the function, and then work it out to see what the output is. All right, now let's take a look at some examples. Okay, in this first one, you can see here that we have f of x equals 4x minus 20 divided by x squared minus 25. Now, we are going to factor it, but if you want to, at the very beginning, you can look for the horizontal asymptote by considering the rules that we said. Notice this one has a degree of 2 in the denominator and a degree of 1 in the numerator. So therefore, this is what we would call bottom heavy, or the denominator heavy. That means our horizontal asymptote is at y equals 0. Well, if we know that, we already know that we're not going to have an x-axis, because the x-axis is y equals 0, so now we're going to have an x-intercept. An x-intercept, okay? But as we simplify this, we can see that 4x minus 20, we can factor out of 4, and we're left with x minus 5. In the denominator, we have the difference of 2 squares, so we factor it x plus 5 times x minus 5. And then you see the common factor is x minus 5. Well, with that being the case, then, you would not be able to plug in a 5 into this function, because if you did, 5 minus 5, you'd have a 0 in the numerator and a 0 in the denominator, okay? So this x value of 5 is going to create the hole. Our function simplifies down to 4 over x plus 5 for all values of x that are not equal to 5. But based on that understanding of 5 creating a hole, what we do is we take the 5 as the x value, we plug it into the to the function, to our final function. So 4 divided by x plus 5, well, we plug in 5 for that x, and 4 divided by 5 plus 5 is 4 over 10, and that simplifies to 2/5. So the point at 5 2/5 is a whole. Now, when we look at the vertical asymptote, okay, the vertical asymptote is when we just set the denominator equal to 0. And remember, what we're using is 4 over x plus 5. So when we do that, we have the denominator of x plus 5, so we simply set x plus 5 equal to 0, and we know that x is -5, okay? So our vertical asymptote is at x equals -5. Now again, this example shows you how to find the x-intercept, okay? But the x-intercept, to find that is when you plug in a 0 for the y value. So if you have 4 over x plus 5 is your function, y equals that, then what I did here is I basically just wrote that function, 4 divided by x plus 5, and I set it equal to 0. Well, because of this fraction here, the denominator being x plus 5, I'm going to clear that out by multiplying both sides by x plus 5. But when you do that, it cancels on the left side, and then 0 times x plus 5 on the right is just 0, so really you just have 4 equals 0. So the numerator equals 0. So the shortcut for finding the x-intercept is just to always set the numerator equal to 0. Now in this example, 4 is not equal to 0, so we say that we do not have an x-intercept. We also knew that because we do not have we know that the horizontal asymptote is at y equals 0, which means our function is approaching 0 but never touches 0. If it never touches the x-axis, then you do not have an x-intercept. Okay, and then finally, the y-intercept is when you plug in 0 for x and just work it out and see what the outcome is, or the output. So 4 divided by x plus 5, we plug a 0 in for x. That's 4 over 0 plus 5, which is 4 over 5. So our y-intercept is at 0 4/5. Okay, here's one more additional example that I would like to show you. I'm going to go ahead and zoom in a little bit here. So we have the function x squared plus 5x divided by 2x squared plus x. You'll immediately notice that the degree of the numerator and denominator are the same. So to find the horizontal asymptote, we can use the leading coefficients, which is 1 over 2. So 1/2 is my horizontal asymptote. If that's the case, then the asymptote, the parent function asymptote of y equals 0 has moved up to y equals 1/2, so we know we're going to have an x-intercept. By the way, we should identify this as y equals 0. I'm sorry, y equals 1/2. Okay, now that we know that, let's talk about, let's go ahead and factor our function. When you do so, you can factor out an x in both the numerator and the denominator. So you're left with x times x plus 5 divided by x times 2x plus 1. So we then can simplify this by canceling out the x's. An x divided by an x would be 1, so we could rewrite this function as x plus 5 divided by 2x plus 1. This is a function we're going to use to determine the other features of the function or of the graph. Now this is true for x not equal to 0. When you cancel out an x in the numerator and the denominator, what you then have is that x equals 0 creates the whole. So you cannot plug in a 0 for x. All right, so if we were to go to that, now you can see here that again, when 0 is the x value, the output that you get, that would be the point that represents the whole of the function. So x plus 5 divided by 2x plus 1, plug in that 0 that we determined at the beginning is the x that creates the whole, and 0 plus 5 is 5, 2 times 0 plus 1 is 1, and 5 over 1 equals 5. So we have a whole at 0, 5. Now real quick, pay attention, if your whole is 0, 5, then you should recognize this as the y-intercept. A y-intercept is whatever the value is when x is 0, or whatever the point is. Well, if this is 0, 5, this is the y-intercept. However, if this is our whole, then we do not have a y-intercept. There would be no y-intercept in this example, okay? And then, of course, we can consider the vertical asymptote. We just take the denominator of 2x plus 1 and set it equal to 0, and 2x equals -1, so x equals -1/2. That's our vertical asymptote, okay? And then finally, the x-intercept is where we simply plug in. So remember that to find the x-intercept, basically we're going to plug in y for 0, or we're going to set the whole function equal to 0. But again, we basically will be canceling out the denominator by multiplying both sides by the denominator. So really we're just setting the numerator x plus 5 equal to 0, so therefore x equals -5. So your y-intercept then would be, your x-intercept would be -5, 0. All right, and that's a couple examples for this lesson.